right now. We're going to talk about what in the heck is going on. So, we talked yesterday that we really have to get comfortable with both notations. So this means the same as this. And I use sine as my example, but it's the case for all of the functions. So cosine, then arc sine, you can have arc cosine, then arc tangent. This is kind of the older fashioned notation. This was like, when I was in school, like your age, this is all there was. When the calculators came into play, then they started using more calculator-friendly notation. But these are the same. They're absolutely identical. So how this works is exactly the way all inverses work. If we know the sine of pi over 6 is a half, right? We know that. Then there's your x, there's your y. The inverse switches those, remember? So it would say this. So the angle whose sine is a half is pi over 6. That's what this says. This means the angle whose sine is 1/2. So in a normal problem like we've had on our other quizzes, I gave you the angle, you looked at the unit circle and found the y coordinate, right? Now, I'm giving you the y coordinate and you're telling me which angle that matches up with. Now, there's a problem with that. And I think Alex already has it figured out. What's the problem, Alex?
There's 2 answers.
Actually there are infinitely many answers, right? There's lots of angles, right? And that's problematic because if you are going to put something into your calculator, it has to be a function because the calculator is only capable of giving you one answer, right? So we know what a sine curve looks like. A regular old sine curve looks like this. That is a function. It passes the vertical line test. However, its inverse is not a function, which is what Alex just said basically, because it doesn't pass the horizontal line test, which means there are repeated y's in that thing. There are repeated y's. So when you flip the ordered pairs, those repeated y's become repeated x's, and we have trouble. Got it? So what somebody a long time ago did was say, all right, when we're considering inverses, we're not going to look at the whole picture because this thing is not one-to-one. So we're only going to look at the part of the sine curve from negative pi over 2 to positive pi over 2. Because if I only look at that part, now is it one-to-one? Yep. And that means that one input will give one output no matter which direction you're going. The original function and the inverse. You're going to get just one answer. Now, what does that mean for us? Well, that means that anytime we see this notation, anytime we see inverse sine notation, whatever answer you write down has to be between negative pi over 2, and pi over 2. Okay? Has to be between them. So when Alex said, we have a problem here, because the angle whose sine is 1/2 could also be 5 pi over 6. Think of your unit circle. Would you agree with that? 5 pi over 6. Problem is 5 pi over 6 in this interval? No. So we can't consider it. We can only consider answers to a sine problem. Now it's going to be different with the other functions. But for an inverse sine, we can only consider answers on your unit circle over here. This is where you're going to look. So again, remember, in an inverse problem, I'm gonna give you the y value, talk about sine now. I'm gonna give you the y value, and you're gonna give me the angle. But you're only looking at this part of the circle. So there's only one answer, okay? Now, what about cosine? Well, you have to do the same thing with cosine, because if you graph a cosine curve, it looks like that, pretty much. I'm gonna stop here, and you know it goes on forever and ever, right? That is not one-to-one, agreed? Not one-to-one. I gotta make it one-to-one. Now, if I picked the same interval that I picked for the sine, which is this interval right here, that would be this part of the cosine curve. Is that one-to-one? No, can't pick that part, because that's not one-to-one. So with a cosine, we pick this part. Is that part one-to-one? Yes. So what are the principal values of the inverse cosine? The inverse cosine is 0 to pi. So any problem you're doing with an inverse cosine, you're looking at that part of the circle. Oh my gosh, Mrs. Ford, do I have to keep this straight? Yes, yes. So inverse sine is a right-hand function, so on the right side of the circle. Inverse cosine is a top side, on the top side of the circle. So if you have a problem like this, find the angle whose sine is, let's say, -1/2. You're thinking about this part of the circle, and you're looking at x values now, right? Where is the x value -1/2? Like right here? Actually, more like right there.
2 pi over 2.
What angle has a -1/2 √3/2? What angle is that? 2 pi over 3. So the answer to this question is 2 pi over 3. All right, let's do tangent while we're here. Think about what a regular tangent looks like. Is that 1-to-1? By golly, it is. So the principal values of the inverse tangent are exactly the same as the sine. -pi over 2 to pi over 2. We don't have to mess with that one.
Wouldn't it be all of it? Like, wouldn't it be any x? Like, since it's already 1-to-1, don't you?
Well, no, it's not. The part I drew is 1-to-1.
Oh, yeah,
Remember,
because they stack
it
on
looks
top
like
of each other.
this,
Yeah.
right? So no, it's not 1-to-1. But if I look at only that piece of it, it is 1-to-1. So if you're doing an inverse tangent problem, you will look at the same part of the circle as the sine. So inverse sine and tangent, every answer has to be between those two numbers. If it's an inverse cosine, every answer has to be there. Okay? So real quick, let's look at your quiz question. One of them anyhow. One of them said, find 3 times the angle whose sine is 1/2. Now forget about the 3 for a minute, that's just a coefficient. All right, this is a sine. So I'm going to be looking here. I need the sine to be 1/2. That means y is 1/2, right? What angle has a y value that's positive 1/2? Pi over 6. So we are doing 3 times pi over 6. Did anybody who had that quiz, that was number 2, anybody say pi over 2 was your answer?
I had 2 answers though.
Okay, now you understand there can't be 2, right?
Yeah.
Okay, and then the other one said 2 times the angle whose cosine is a half. 2 times the angle whose cosine is a half. So if you're doing a cosine problem, remember, you're only looking up here. Cosine is x, so somewhere my x coordinate is a half. What kind of an angle has an x coordinate of a half? Pi over 3. So we're 2 times pi over 3. Anybody say 2 pi over 3 for that one?
I did the same thing as
You had
Declan.
2
I
answers?
said
Which is
2 pi over
completely
3
understandable.
and then 10 pi
But
over
now we know, right?
Will it
Now
still
we know.
count for close?
Huh?
Well, like if you put 2 answers, will it
I'll
still
give
count?
them 1 if they have the right angle.
I need that 1 too.
All right, let's look at some problems now and figure out what's going on. Okay, so we talked about all that, All right, let's go to example 2. Evaluate the following expressions. So take a minute, and see if you can find the angles in example 2. Remember, they have given you a coordinate, and you gotta match it up with the right angle in the right part of the circle. So see if you can do 2, A, B, and C. See if you can find the angle. One answer. So for the first one, we're doing a cosine problem. That's your x coordinate, right? The x coordinate is negative root 2 over 2 over here somewhere. What angle has an x coordinate that's negative 1 over root 2 or negative root 2 over 2? What angle is that?
3 pi over 4.
3 pi over 4. 3 pi over 4. Alright, how about this one? Now I'm on the right half of the circle, y, and it's negative. So what point, or not what point, what angle has a sine or a y value that's negative root 3 over 2? I heard 5 pi over 3. Let's talk about that for a second. That is absolutely in the right spot. The problem is I can't name it that way because what is my domain? All or my range? All my answers have to be between negative pi over 2 and pi over 2. Is that number in between those? Now, I didn't ask, is that angle located on that part of the circle? It is, absolutely. But is that number, whatever decimal that is it between negative 1.57 and positive 1.57? No. So we can't name that angle this way. How do we have to name it? Negative pi over 3. The answer is negative pi over 3. Okay, so this is a big sticking point, but we don't get to decide, we don't get to change it. It is what it is. Every angle you name, if it's an inverse sine, it's got to be between negative 90 and 90. It can't be 300. Okay, so it's the same angle, same spot, okay, but you gotta name it differently.
Why is it negative 5 over 3? Like, why?
Instead of what?
I just,
Well,
how did
if
we
we go
get
back to
negative
the
5 over 3?
picture I had before, where I drew my sign, here's negative pi over 2, here's pi over 2, and we said every answer had to be on that part of the sine curve. Okay, 5 pi over 3 is clear out here.
No, I get that, but how does 5 pi over 3 equal negative pi over 3?
Well, all the way around is 2 pi,
Okay. Oh, and you just take, oh, okay.
so it's 6/3.
Yeah.
But what's the point of doing it? If they're the same thing and they're saying the same thing, what's the point of changing it?
Because when you type this into your calculator, you have to get one answer. And so in order, and there are infinitely many answers. There are infinitely many angles that are assigned a negative root 3 over 2. So to make it meaningful in problem solving, we need one. So the one that was kind of uniformly accepted a long time ago by someone who made up all this stuff is that part right there. That's the part we look at. Otherwise, you'd have a zillion different answers. Right?
Yeah.
Even to the problem on the quiz. If I didn't have rules that I have to follow, there would be infinitely many answers to this question. And we need to have just one. Okay? To make it a function. We want it to be a function. Okay, and then this guy. Now this one you have to think a little bit more about. You want the tangent to be positive. Clearly you're up here somewhere, right? And you need y over x to be root 3 over 1. So isn't your ordered pair 1/2 root 3 over 2? In order to get the tangent to be root 3 over 1? And what angle is that? Pi over 3. And we don't have to worry about it because it's positive pi over 3 and that's it.
So if it was, negative root,
It would be the same as this one.
so it'd be just negative.
Yeah. Yep. Sine and tangent are handled exactly the same way. All right, let's look at example 3. Do not let all the letters and dotted lines and all that stuff mess you up. This is a unit circle, and point P has coordinates x, comma, y. All right, so now he's asking you, okay, for A, where is the angle whose cosine is x? All right, now wait a second, doesn't that have to be on the top half of the circle? So the only 2 points possible would be P and Q. What are the coordinates of point Q? Negative x, y. This doesn't say negative x, this says positive x. So what point does A refer to?
P.
P. P. All right, now what about B? Now you're only allowed to look at the right side of the circle, which means your answer is either gonna be P or S. It's either gonna be P or S. Which one is it? S because the Y is negative? Alright, what about C? Where is C? Gotta be Q. Gotta be Q. You're on the top half of the circle. And then what about D?
Yes.
It's gotta be point S. Very, very good. Very good. No inverse functions are gonna be R. Nothing's in quadrant 3. Alright. Next page, number 9. We're not gonna do all of this, but I want you to do problem 1 real quick. These are not inverses. These are unit circle practice problems. So here we go. Unit circle practice 1, or number 1, A, B, C, D. Let's get some answers to those.
This one.
Yep.
For D on the last one I just did, could it be? Would it Q and S?
No, remember, inverse tangent only exists on the right side of the circle.
Okay.
So your only possible answers would be P and S for a tangent problem. Anytime you're doing the inverses, which is not what you're doing in problem 1 now, but anytime you're doing something with the inverses, you've got to restrict yourself to only part of the circle. The better your command of the unit circle, the easier all this is gonna be. What did you get for the sine of 7 pi over 6? Negative 1/2, very good. How about the sine of negative pi over 6?
Negative 1/2.
Negative 1/2. How about the sine of 11 pi over 6?
Negative 1/2.
See why we have to have rules? And then how about 19 pi over 6?
Negative
They're all negative 1/2. They're all different angles, but they're all located where the sine is gonna be negative 1/2. So, think of all those different angles that gave you negative 1/2. What is the answer to this? So in other words, if the sine is negative 1/2, which one angle are you gonna choose?
Negative 5 over 6.
Negative pi over 6. Because that is the only one that is in between negative pi over 2 and positive pi over 2. All right, turn the page. Check your understanding. Here we go. Do number 1. We'll do a check and then we'll go back and do, we're going to do some more. What'd you get for one A?
What number?
One A? What'd you get? Negative pi over 4, that's exactly right. Negative pi over 4. Does everybody understand, first of all, why it's pi over 4? And then why it's negative? Okay? What'd you get for B? Negative pi over 6. Negative pi over 6. Think of root 3 over 3 as 1 over root 3. So it's like 1/2 over root 3 over 2. And then what about C? Not possible. Not possible. What that question is asking you is, what is, it says literally, find the angle whose cosine is 9 point something. 3 pi, 3 times 3. Can you have a cosine that's 9? No. In fact, you can't have a cosine that's more than 1. 1. Adjacent over hypotenuse cannot be more than 1. That's a no solution. All right, number 2 is interesting. I'll give you a hint. One of these is true and one of them is false. So let's literally read question A. Find the angle whose sine is the sine of 5 pi over 6. That's in words, that's what problem 2A says. This notation means find the angle. So we are gonna find the angle whose sine is that number. Okay, well what's the sine of that number? What's the sine of 5 pi over 6? Just this right here. What's the sine of 5 pi over 6?
1/2.
1/2. 5 pi over 6 up here in quadrant 2. Isn't that 1/2? So this is 1/2. So now we are finding the angle whose sine is 1/2. Okay. What is the angle whose sine is 1/2? Wouldn't it be right here somewhere? What angle is that that has a y value of 1/2? Isn't that pi over 6? So the answer to the question is pi over 6. The answer to the question is not 5 pi over 6.
You just rule it out right away because you know the arc sine can't be over pi over 6.
Yep, you absolutely can. What I kind of want to go through it with you is, normally, inverses are going to cancel each other out. So if you see an inverse sign backed up right with a sign, normally, well, they're just going to cancel out, but not here. Not with these guys. You're right. The answer has to be between negative pi over 2 and pi over 2.
So for the second one, it, like just to shortcut it, like I know how to do it the long way, but because inverses usually do cancel each other out, if that one is within the range of that
Yes.
function, then you
Yes.
can just cancel them.
Yes. Yeah. Now, B says, find the cosine of the angle whose cosine is negative root 2 over 2. Well, the angle whose cosine is negative root 2 over 2 is 3 pi over 4. The cosine of 3 pi over 4 is negative root 2 over 2. That is a true statement. These things can get crazy. All right, 3A. How many solutions, if you were just walking down the hall and found this equation with no instructions, just that equation just laying there, how many solutions would there be? Infinitely many. Because if you think about your tangent curve, branches it has, how many times does the tangent curve cross where y is -1? Doesn't it cross with every branch? So there'd be infinitely many. Anybody know the angle whose tangent's -1? What would be one of them? There's infinitely many of them. What's one of them?
Set 5 pi over 4 is,
Be careful. I
Oh,
need
wait,
to
no.
a -1.
3 pi over 4 and 7 pi over 4.
3 pi over 4 and 7 pi over 4, those would be a couple of examples. There are tons more, but that would be a couple. How many answers are there to this question? The angle whose tangent is -1.
One.
1. And what is it? -pi over 4. Very, very good. -pi over 4. All right, number 4. Let's see if you know what you're doing or not. This is kind of tricky. See if you can figure out, there's only one of these that's false. See if you can figure out the one that's false. Only one of them. All right, anybody figure it out? Which one? Which one? Why? You're right. Why do you think it's C?
That's what I put down.
Why did you put it down then?
Because like it's on there, it's just like it's where I don't know. Like I see it. I don't know how to explain it. I like see it in my mind.
Yeah, I mean,
Because in the inverse, the range, or, no,
yeah. No, you're right.
is it the range?
Has to be between.
Yeah, it has to be between, 0 and pi.
Exactly. So right here for the inverse of the range, which is the domain of the original, so it gets all confusing, but yes. So this for cosine has to be between 0 and pi. So can you have a y value that is something plus 2 pi? No, out. C is false. Absolutely. Good job. Okay. Turn to the back of page 10. We're going to solve a trig equation before we run out of time. There's one equation. All we have time for today, but we will do more.
No.
Okay? So find all the solutions to this equation. All of the solutions. Now, do you literally see in the problem this notation. Is that notation in the problem? No. Therefore, there are no rules, okay? This notation is the one with the rules that says you can only look at a certain part of the circle. If you don't see that notation, then you're not playing with those rules. You literally want to find every single angle that has a cosine of negative root 2 over 2. So where would that be? Here's my circle. What parts of the circle would have a cosine that's a negative number? Here and here, right? Don't those have an x-coordinate that's negative? What angles are those? This angle is 3 pi over 4, and this one is 5 pi over 4. So for sure, would you say 3 pi over 4 and 5 pi over 4 are two answers to this question? But there are more. Give me another one. Alex?
You could do negative 5 pi over 4.
Negative 5 pi over 4 would be right here. Would you agree with that? So that's another answer. Are there any others, or is that it? There are infinitely many. So if you want all of them, you have to do one of these numbers. Because any angle that is coterminal with these, right? Any angle that's coterminal is going to end in one of those spots. So your answers are there. Infinitely many of them. When you're not playing with any rules, you're going to get a bazillion answers. And that's what we've got here. So why am I adding 2 pi? Because the period of a cosine is 2 pi. If this had been a tangent problem, I would be adding pi's. All right, good deal. We'll pick up here tomorrow.